Hello everyone, welcome to the fourth and final video covering examples from Chapter 9. And in this video, unlike the first three, we're going to be going over two-way ANOVA models. So you can see the example on screen here, but in summary, we have two variables, soil pH and calcium, and we're going to analyze to see how those two variables interact and how they might have an effect on trunk diameters for different orange trees. Going into a bit more depth here, we have 4 different levels for the pH variable, ranging from 4 to 7, and then 3 different levels for the calcium, 100, 200, and 300. And we have 3 different observations for each of the factor level combinations for the 2 variables. Alright, so we can move over to SAS to start the analysis. So like the rest of the videos in this chapter, I'm going to start off with the options command just to make the output a little bit more user-friendly. Then we're going to import our data. Here we're going to import the 3 variables, diameter, calcium, and pH level. Then we're going to use the data lines and then paste our data in, then close it with a run command. And then like always, I'm just going to run this to make sure that my data is properly being read. So highlighting it all. Looks like everything is in order here. Doesn't look like there's anything missing. Alternatively, you could run a procprint function after importing the data and use that to check if there's anything missing. You get a nice visually pleasing table out of it as well, so it's really up to preference at this point. So if we run the procprint here, we can see all of the data seems to be in order again, and then we can head back over to the code tab and we can start the analysis. So then we're going to run procmeans, but we're not going to run it in the way that we've typically seen it so far. In this case, we're going to use the option no print. So with this no print enabled, you won't get the typical table that you expect to see with the procmeans command. Instead, in a couple of lines, we're going to find this as a data table that we're going to call back later. However, like the typical procmeans function, we're going to use that var diameter to define which variable we want summary statistics for. So this line here allows us to break out the means function into the different calcium and pH levels. And then we use this not sorted option, and that way we can analyze the data without having to sort it in a specific way. And then finally, we're going to use the output function and out equals outmeans to create a temporary data table with the name outmeans. Then we're going to drop the 2 variables type and frequency, and we're going to rename the variable mean to diameter mean. And then we're going to close that off with a run command. So if we run this, we're just going to get a generic bland looking table in the output data tab. However, if we wanted the table that we are accustomed to, we can use the procprint function and then specify the data as the output that we had just created with the procmeans function. So if we highlight that, we can get the table that we expect. And then looking at the values in the table here, there doesn't seem to be any sort of distinct pattern that sticks out right away. So it might be more beneficial to look at something like a interaction plot. Luckily, an interaction plot is given with the GLM function, so we can use that procglm to actually model our data. We use class pH and Ca to denote our 2 factors, and then we use model diameter equals pH Ca, pH asterisk Ca, and that term with the asterisk denotes the interaction term between the 2 factors. And then lastly, this means option gives us the different means for the subsets of the data. So each level of the pH and each level of the calcium, as well as the combinations of both. So it outputs 3 separate plots of the different histograms, as well as tables featuring the different subset of the variable combinations as well. So if we go ahead and run this cluster of code, we will see various outputs relating to the ANOVA model featuring the interaction effect. So looking at either of those bottom 2 tables, we can see that it lists the 2 main effects as well as the interaction effect. Looking at that rightmost column, we can see the p-values associated with those terms. The most important of which is the interaction term, And since it's significant, we can reject the null hypothesis and can conclude that the two main effects do indeed interact. Given that the interaction effect is significant, it's difficult to interpret the main effects. However, the interpretation for the interaction effect is made easier with the interaction plot below. So right away, we can notice that the lines in the interaction plot are nowhere near parallel, and that is because there's a significant interaction between the two main effects. So we can make some notable observations about the interaction plot. So the first of many possible interpretations is that, say for instance, the pH level 4, calcium level 100 is the lowest diameter, and then the largest growth in diameter happens at calcium level 100 and then moving from pH level 4 to 5. Other observations include the fact that pH level 6 and calcium level 200 yields the largest diameter for the tree trunk. And then you could also say that pH level 5 yields very similar results no matter what the calcium level as well. So I hope I've made it evident that there's no shortage of interpretations that can be extracted from the interaction plot. And it just goes to show that, in fact, the significant interaction term exists because of these unparalleled and semi-unpredictable lines constructed in this interaction plot. But rounding out this output, as we scroll down, we can see the distribution histograms of the different subsets of the data. So for instance, this one was looking at the pH level, and then scrolling down a bit further, we can see the means for that as well. And then scrolling down, we also saw those histograms for the other main effect, as well as the histogram and table of means for the different combinations of the main effects as well. And then next, we're going to conduct that same analysis. However, we're going to remove the interaction effect. So the code for running the two-way ANOVA with the main effects only is very similar to the one with the interaction effect. However, this time we're going to specify that we would like a Tukey comparison because we would like to see which of the factor levels is in fact different, assuming the main effect is still statistically significant. So running the new model, we can see the output is very similar to the one with the interaction effect. So we can see from either of those two tables that the p-values are well below 0.05 for both of the main effects. So that means that for both pH and calcium, there exists at least one factor level that is significantly different from the others. And then one quick note about the interaction plot. This time we can notice that the lines here are parallel, and that is a result of removing the interaction term from our model. So we just have the main effects. So up next is the table for the Tukey comparisons, this case for the pH level comparisons. So we can see here that the comparison between pH level 6 and 4 is statistically significant, as is 5 and 4, and then those again are repeated at the bottom of the table. And then we can scroll down a bit further, so in that way we can see the Tukey comparison for the different calcium levels. And in this case, we can see that the comparison between 200 and 300 is statistically significant. And so that brings us to the end of our fourth question, our final video covering Chapter 9. If you have any questions, please reach out. And thank you very much for watching.